guys, and welcome back. Welcome to episode number 2 of this series, Malicious Attack Vectors, where we explore all of the intricate ways a threat actor or an adversary could effectively harm your cluster or harm your environment. We do this, of course, for educational purposes, to effectively give you an idea of the type of things you should really be thinking about when it comes to Kubernetes security. Without further ado, as you probably guessed, or you've maybe even read the title, we're looking at static pods. So a threat actor wouldn't really consider static pods unless your system's already been compromised. We've already spoken quite extensively about how you could effectively tighten your cluster to prevent this level of compromise, of course. For more information, please do check out the playlist that I created around all the different toolings you could potentially use to keep your environment safe. Now, assuming your system's already been compromised, we're going to look at what a threat actor could effectively do. This would be another one of the quote-unquote lateral movements that an adversary may take to further exploit your system, and that is in the form of static pods. So static pods are exclusively maintained or looked after by the kubelet service. So the kubelet is a daemon set. Effectively, it's a service that's running. So if you hit systemctl, if I could spell that right, so that is kubelet. It's running as a service, as opposed to a deployment. Now, what that means is we have an instance of the kubelet running on all nodes. Now, that is quite handy, but what that effectively means is with the static pods being taken care of by the kubelet, we cannot effectively access. I mean, we can, but we can't necessarily make changes to the static pods via the kube API server. And we'll look at that in just a moment. So if we get into where the actual static pod manifest files are stored, we can see here within this directory in the etc Kubernetes manifest, we've got here the etc YAML file, the kube API server, the kube controller manager, and the kube scheduler. These are all the main components for the control plane. Of course, as I am currently operating within the control plane. Now, the adversary would effectively and simply need to store a manifest file within this actual directory in order to deploy that static pod. And we'll look at all the different ways that we can effectively mitigate that. But before we do that, we're going to do exactly that. So I've already made a manifest file, malicious manifest file. Again, doesn't deploy anything dangerous to this environment anyway. And even if it does, it's obviously a sandboxed environment. So I'm going to move the file to this directory. Let me quickly get out of there. Cool. So let me cd back into where that was. Mv that kube threat actors pod into the kube. Actually, before we do that, let's view the threat actors pod. There's quite a bit going on. Named it suspicious pod. Obviously, it's just a name. It could be generic. Typically, what the threat actor will do, they'll probably give this a pretty subtle name. They wouldn't necessarily name it anything that will obviously gain side eyes. Effectively, we'll give this. Oh, mind me on the image name. Give it a legit image so it does run. So we've got the image Nginx. Obviously, it will be an untrusted image from wherever they're pulling from. It's running as a privileged indexed container privileges, which can obviously lead to further attacks. Capabilities are set to all, giving the container full access over the host, which is quite dangerous, of course. And the host network is set to true, meaning that this is going to effectively allow the threat actor to make continual movement through the network. We've got a command running at the moment. It's a shell command, and that's currently looping. All it's doing in this case is it's just echoing malicious activities, just printing to screen. But you can imagine it wouldn't the adversary wouldn't necessarily be running such innocent commands. It would be obviously probably making some it could even effectively recruit your system or the container as a bot within a botnet for a DDoS attack or so on and so forth. And obviously these come with their relevant mitigations, and we'll look a bit deeper into them in just a moment. So I'm going to move this cube the threat actors pod into that manifest. And now if I hit K get pods and we set that to watch, we can see that suspicious pod is now running. Now, interestingly, what we will do is we're going to attempt to delete this pod. If you remember what I mentioned about the kubelet and the kube API with regards to static pods, you will know what will effectively happen. But we'll look at it anyway. So we'll say kube delete pods, and we'll call this suspicious control plane. It's going to tell us it's deleted, but what will happen will be that it will effectively spin right back up, because again, it's a static pod. Now, static pods come with the suffix of the node that it runs on. So the threat actor may not necessarily be naming it with, again, such an innocent name. You may effectively name it one of the regular sort of pods that will effectively be running in that node anyway, like the Kube API server. Perhaps you may take it down or rename his own, their own pod with the name of that original pod, if that makes sense. So, as you can imagine, this is obviously quite dangerous. I mean, if we look at mitigations from this point, then we're going to obviously want to understand. If we go back to, let's see, Kubernetes manifest, or VI into that. Threat actor pod. So I've set the mitigations directly under the different vulnerabilities within this actual manifest file. So here for the mitigation, to mitigate the image, the untrusted image, of course, you're going to make sure you want to only use trusted images from verified repositories. You can do that through setting admission controllers that effectively validate each of and every webhook through your system. So you can set something called OPAs up, open policy agents, which allow you to effectively deploy custom code that will effectively validate those different webhooks for privileges, for mitigating privileged privileged containers. Then effectively you could set up that same sort of validation, making sure that any kind of webhook that is being sent to your API is checked for that too. You could effectively do that for each and every one of these different components here, these different exploits within this actual manifest file. You could set resource quotas for the different containers that are deployed within the area. Another one you could effectively set up is FileCall. FileCall is quite handy. FileCall runs as, again, a daemon set, a service. So you could do systemctl status FileCall. You see it running. If it isn't, then you could set that to start running. And then hopefully check the status to see it running. I think in this case, it may be down, but it effectively does run as a service. And what that will do is you could potentially set up a FileCall rule. Again, I made I think a few videos on FileCall. It's quite an interesting tool. It can sit as a kind of an emulation. It kind of emulates the idea of an IDS. It's a closest emulation to an intrusion detection system, where you can set custom rules to make sure that users don't access the various or the sensitive folders, like the static pods, where the static pods live, within the manifest folder under the subdirectory etc Kubernetes manifest. So that's that. That will effectively conclude this. Obviously, there are a number of different ways you can mitigate this sort of attack, but it was just another interesting one that, you know, kind of caught my eye. I thought it'd be handy to share with you guys. So yeah, let me know what you guys think about that. If you guys are you know, enjoying this series, then most definitely give it a thumbs up. Give us a comment down below what you'd like to see in the future. And yeah, got more of these sort of videos coming up. Make sure you do check out my socials like the LinkedIn and all the other ones that are down below. Cheers, all the best.